Hey everyone, AMX here. Ready to start your web development journey? Today we're breaking down the absolute essentials of JavaScript, the language behind interactive websites and apps. We'll focus on the 10 core concepts every developer must know, from variables to async operations. No fluff, just the fundamentals you need to start coding with confidence. By the end, you'll have a solid foundation to tackle more advanced topics. So grab your favorite drink, open your code editor, and let's dive in. Let's start with variables, the essential containers for your data in JavaScript. Think of variables as labeled boxes where you can store information, retrieve it, or even change it later. In JavaScript, there are two main ways to declare variables, using let and const. Each serves a different purpose, and choosing the right one helps keep your code clean and predictable. Use let when you expect the value to change over time, like a game score, a user's age, or the number of items in a shopping cart. With let, you can update the value as often as you need throughout your program. For example, if you're building a counter that increases every time a button is clicked, let is perfect for that job. You can start with let count bots naughty 0 and then update count as the user interacts with your app. On the other hand, use const for values that should never change after they're set, like the number of hours in a day, a tax rate, or a configuration setting that stays the same. Const stands for constant, and it locks the value in place. If you try to reassign a const variable, JavaScript will throw an error. This is a helpful safeguard to prevent accidental changes to important data. It's also important to avoid using var, the older way of declaring variables. Var has confusing scoping rules that can lead to bugs and unexpected behavior. Instead, stick to let and const for clarity and reliability. To recap, use let for data that might change, and const for data that should stay the same. This simple rule will help you write code that's easier to understand and maintain. Here's a quick example. Let score, Yakard 10. Yakug, this can change as the game progresses. Const pi, Yakard 3.14. Yaka, this value shouldn't change. Variables are what make your code dynamic and flexible. They allow your programs to react to user input, store results, and keep track of changing information as your app runs. Mastering variables is your first step to real programming. Once you're comfortable with let and const, you'll be able to build interactive, responsive applications that do exactly what you want. Now let's explore the different types of data you can store inside these variables, and see how they bring your code to life. Every variable in programming holds a value, and understanding what kind of value it holds is essential to writing effective code. And every value has a specific type that determines how it behaves and what you can do with it. Let's start with the basics. In JavaScript, the most common data types you'll encounter are strings, which are sequences of characters used to represent text, like names, messages, or any words you want to display. Numbers, which include both integers and decimals. These are used for anything involving math, calculations, or measurements, and booleans, which are simple true or false values. Booleans are the backbone of logic in your code, helping you make decisions and control the flow of your programs. Use strings when you need to store words or sentences, like a user's name or a product description. Use numbers for anything that involves counting, adding, or comparing quantities, like scores in a game or prices in a shopping cart. And use booleans when you need to check if something is true or false, such as whether a user is logged in or if a form is complete. There are also special types you'll encounter. Undefined means a variable has been declared but hasn't been given a value yet. It's like an empty box waiting to be filled. Null, on the other hand, is used when you want to intentionally indicate that a variable is empty or has no value. Arrays are another important type. They're ordered lists that let you store multiple values in a single variable, like a list of names, scores, or items in a shopping cart. Objects are used to group related data together. Think of them as mini databases for a single thing, like a user profile with a name, age, and email all bundled together. Data types really matter. For example, if you try to add two strings together, you won't get a mathematical sum. You'll get concatenation, which means the two strings are joined end to end. But if you add two numbers, you get a mathematical result. Understanding the differences between data types helps you avoid common bugs, like accidentally treating a string as a number, or vice versa. It also helps you write code that's easier to read, maintain, and debug. We'll dive deeper into arrays and objects soon, exploring how they let you organize and manage complex sets of data. For now, just remember, the type of a value decides what you can do with it. You can't perform math on a string, and you can't split a number like you would a list. Keeping your data organized by using the right types makes your code more reliable and easier to understand. It's like sorting your tools before starting a project. Everything works better when it's in the right place. Now that you know the basics of data types, let's move on to how you actually use and manipulate this data in your programs. Functions are your code's action takers. They're reusable blocks that perform tasks, like recipes you can call anytime. Classic syntax, call it prints, hello Alice. Modern syntax, arrow functions. Functions keep your code dry and organized. They can take input, parameters, and return results. Use them to break big problems into small, manageable steps. Arrays are lists, perfect for storing collections. Create one. Access items by index is banana. Add with, remove with, loop through with, transform with. Arrays can hold any type, even other arrays or objects. They're essential for handling lists, data, and more. Next, let's organize data with objects. Objects are like dictionaries, collections of key value pairs. Example, access data with dot notation is Sarah, or bracket notation is 32. Objects can store any type, including arrays and functions, methods. Add a method. Call it. Objects let you group related data and behavior. They're the backbone of most JavaScript apps. Now, let's see how to repeat actions with loops. Loops let you repeat code efficiently. The classic loop, prints 0 to 4, great for precise control. Loops repeat as long as a condition is true. For arrays, use, no need to manage indexes, just the values. Loops automate repetitive tasks and make your code powerful. Use the right loop for the job and keep your code clean. Next, let's make decisions with conditions. Loops and conditions together unlock real logic in your programs. Practice them to master control flow. Let's see how conditions work. Conditions let your code make decisions. Use to check a condition. Add for alternatives. Use comparison operators. Trakada, strict equality. Strict inequality. Always use for safe comparisons. Chain multiple checks with. Conditions control your program's flow, showing different content or running different code based on data. They're essential for interactive apps. Combine them with loops for dynamic logic. Next, let's talk about where your variables live. Scope. Understanding scope prevents bugs and confusion. Scope controls where your variables exist and are block scoped, only available inside where they're declared. Example, functions create their own scope. Variables inside are hidden from the outside. Is function scoped, not block scoped. Avoid it to prevent weird bugs. Use and for predictable, safe code. Scope keeps your variables organized and prevents accidental overwrites. Next, let's handle code that doesn't run instantly. Callbacks. Some tasks take time, like loading data or waiting for a click. Callbacks let you run code later, after something finishes. Example, the function you pass is the callback. It runs after the timer. Callbacks are everywhere. Event listeners, data fetching, and more. They're the foundation of asynchronous JavaScript, but too many callbacks can get messy. That's where promises and async await come in. Let's make async code easier to manage. When working with JavaScript, you'll often need to handle tasks that take time, like fetching data from a server or reading files. Promises are a powerful tool that make asynchronous code much cleaner and easier to manage than the old way of using callbacks. A promise is like a placeholder for a value you'll get in the future. Either the operation succeeds and you get your result, or it fails and you get an error. This helps you write code that can react to both outcomes in a structured way. You use the .then method to handle success and .catch to handle errors. This chaining lets you build a sequence of actions that happen one after another, making your code much more readable. Instead of deeply nested callbacks, which can quickly become confusing and hard to debug, you simply chain your actions together with promises. This approach is often called callback hell when using old-style callbacks, but promises help you avoid that mess entirely. Your code becomes flatter, easier to follow, and much less error-prone. For even cleaner and more intuitive code, JavaScript introduced async and await. These keywords let you write asynchronous code that looks almost like regular, synchronous code. To use them, you mark a function as async, and then use the await keyword inside it to pause execution until a promise resolves. This means you can write code that waits for data to arrive before moving on, without blocking the rest of your program. It's a huge step forward for readability and maintainability. For error handling inside async functions, use try, catch blocks. This lets you catch and handle errors just like you would in synchronous code, making your async code safer and easier to debug. With async await, your code becomes much more readable, almost as if it's running step by step even though it's still asynchronous under the hood. This is now the modern, recommended way to handle asynchronous tasks in JavaScript, and it's widely used in professional code bases. Mastering promises and async await will help you write better, more reliable, and more maintainable code, making you a stronger JavaScript developer. With these tools, you're well on your way to building robust applications and tackling real-world problems with confidence. You're almost ready to start building real projects. Keep practicing and soon you'll be creating amazing things with JavaScript. You've just learned the 10 core JavaScript concepts every developer needs. Practice is key. Try building small projects and experimenting with these ideas. Create objects, write functions, loop through arrays, and play with async code. Master these basics, and you're ready for the next step. DOM, APIs, and frameworks like React. Keep learning, keep coding, and you'll grow fast. Let me know in the comments what you want to learn next. Thanks for watching. See you in the next one.